Imagine a night very far in the past, when the solar system was still a gigantic chaos of gas, dust, debris, and storms of matter swirling around the young Sunday. There was a celestial body silently growing. It absorbed hydrogen, helium, rock dust, ice, and every piece of matter that drifted across its orbit. Little by little, it became gigantic. Little by little, its gravity became so powerful that it could control the fate of millions of smaller celestial bodies around it. And if that story had been only slightly different, if it had gathered more matter, if it had been dozens of times heavier, perhaps the sky of Earth today would not have had only one Sunday. That celestial body was Jupiter. We are accustomed to calling Jupiter the largest planet in the solar system. But in the eyes of many people, Jupiter also carries a more mysterious, more fascinating, and more controversial title: a failed star. A giant planet filled with hydrogen and helium, the two basic ingredients that create stars. A world so large that more than 1,000 Earths could fit inside it. A giant with the strongest magnetic field among the planets, with dozens of moons orbiting it, with storms large enough to swallow the Earth. But despite possessing all these things, Jupiter still could not ignite. It could not shine by itself like the sun. It could not become a real star. So what prevented Jupiter from crossing that final boundary? Why is it only a planet while its composition is so strangely similar to a star? And if Jupiter truly became a sun, how would the fate of the Earth, of the solar system, and of ourselves change? The story begins more than 4.5 billion years ago, when the sun was not yet the bright sun we know today. At that time, the entire solar system was only a giant cloud of gas and dust collapsing under its own gravity. At the center, more and more matter was pulled inward. The temperature rose tremendously. The pressure became intense. And finally, nuclear fusion was activated. The sun was born. It flared into light, ignited an enormous source of energy, and became the heart of the entire planetary system. But farther away, the remaining matter did not disappear. It continued to collide, gather together, and form the planets. Near the sun, where temperatures were too high, light materials such as hydrogen and helium could hardly remain. So rocky planets such as Mercury, Venus, Earth, and Mars were formed. But farther away, in the colder region, a gigantic planetary core began to grow very quickly. It was strong enough to pull in enormous amounts of gas from the surrounding disk of matter. It grew faster than any other planet. It became a gravitational whirlwind in the dawn of the solar system, and that was Jupiter. From the moment it was born, Jupiter was unlike the other planets. It has no solid surface like Earth. It has no continents, no oceans of water, no ground to stand on. If a spacecraft tried to dive into Jupiter, it would not land on any surface. It would pass through dense cloud layers, entering regions where the atmosphere becomes denser, hotter, and more violent. The deeper it goes, the greater the pressure becomes. Winds howl at terrifying speeds. The layers of hydrogen and helium are compressed so tightly that they no longer resemble ordinary gas. And deep inside, hydrogen is forced into a strange form: liquid metallic hydrogen, an electrically conducting substance moving violently, contributing to the creation of the gigantic magnetic field surrounding this planet. Jupiter is a world not meant for life as we know it, but it is a gigantic natural laboratory where matter is compressed under conditions that humans can hardly reproduce completely on Earth. From the outside, Jupiter appears with bands of brown, white, orange, and yellow clouds swirling around the planet. Upon them is the Great Red Spot, a gigantic storm that has existed for at least hundreds of years, large enough for Earth to fit inside it. A storm that has endured through many generations of humanity, silently spinning on the surface of a planet without ground, like a giant eye looking into the darkness of the universe. But what makes Jupiter special is not only its size. What brings it close to the concept of a failed star is its composition. Like the sun, Jupiter is composed mainly of hydrogen and helium. These are the two most common elements in the universe, and also the basic fuel of stars. The sun shines because in its core, hydrogen nuclei fuse into helium, releasing enormous amounts of energy in the form of light and heat. This is not combustion like a fire on Earth. There is no wood, no oxygen, no flickering red flames. It is nuclear fusion, a process so powerful that it can maintain the light of a star for billions of years. So why can the Sun do that, while Jupiter cannot? The answer lies in one word: mass. In the universe, mass determines the fate of a celestial body. The greater the mass, the stronger the gravity. The stronger the gravity, the more compressed the matter inside becomes. The more compressed it becomes, the hotter the core grows. And when the temperature and pressure in the core reach a sufficiently high threshold, nuclear fusion can begin. The Sun has enough mass to force its core into that state. Jupiter does not. Jupiter may be the largest planet in the solar system, but compared to the Sun, it is still too small. The Sun contains more than 99% of the total mass of the entire solar system. Jupiter, although heavier than all the other planets combined, is still only a very small fraction compared to the Sunday. It has the fuel, but not enough gravity to compress its core to millions of degrees. It has hydrogen, but cannot force hydrogen to fuse into helium. It has a structure similar to a star in a primitive stage, but lacks the most important condition to become a star: sufficient mass to ignite itself through nuclear fusion. In other words, Jupiter is like a gigantic reactor that has been filled with fuel but never reaches the activation temperature. It is a door standing at the threshold of light but forever unable to open. Scientists estimate that if Jupiter were about 13 times heavier than it is now, it could enter the boundary region of brown dwarfs, celestial bodies lying between planets and stars. Brown dwarfs are sometimes called true failed stars because they can form like stars but do not have enough mass to sustain stable hydrogen fusion like ordinary stars. Some brown dwarfs can burn deuterium, a heavy form of hydrogen, for a short period of time, but they cannot shine for long like the Sunday. They are born in darkness, glow faintly, and gradually cool over time like dying cosmic embers. And if Jupiter were about 75 to 80 times heavier than it is now, the story would be completely different. Then it could have enough mass to become a red dwarf, a small star colder and dimmer than the Sun, but still a real star. It would no longer be the largest planet in the solar system. It would be a second Sunday, and our solar system might have become a binary star system. Stop for a moment and imagine that scenario. In Earth's sky, besides the familiar Sun, there would be a faint red star in the distance. Days might be longer, nights might no longer be completely dark. The light from Jupiter in its stellar version might tint the sky with a faint red hue. Jupiter's moons such as Europa, Ganymede, Callisto, and Io might no longer be icy satellites orbiting a giant gas planet. They could become worlds orbiting a small star, receiving light and heat from their own energy source. But together with that beauty comes chaos. A second star in the solar system could alter the orbits of the planets. Its gravity could stir asteroids, disrupt comets, and change the environment of the outer planets. The delicate balances that have allowed Earth to exist in the habitable zone could be broken or transformed in ways that are difficult for us to imagine. Perhaps Earth would still exist, perhaps life would still appear, but certainly it would no longer be the solar system that we know. And the astonishing thing is that all of this did not happen simply because Jupiter was not massive enough. In that cosmic tragedy, Jupiter stopped at a strange position. It was not small enough to be just an ordinary planet, but it was also not large enough to become a star. It stood between two worlds, 1 foot placed in the kingdom of planets, 1 foot touching the edge of the stars. And it is precisely that intermediate position that makes it one of the most fascinating celestial bodies humanity has ever observed. But is calling Jupiter a failed star really accurate? The answer is both yes and no. Yes, because Jupiter has a stellar composition. It contains mostly hydrogen and helium. It is very large, and it emits more heat than the amount of heat it receives from the Sunday. That means there is still an internal energy source inside it, from the process of formation and gravitational contraction. It has a gigantic magnetic field, its own satellite system, and a great influence on the structure of the solar system. If viewed through imagination, Jupiter is very much like a star that never had the chance to ignite. But no, because from a strictly scientific point of view, Jupiter is not a failed star in the true sense. It did not form like an independent star from the direct collapse of a giant cloud of gas. It formed in the disk of material around the young sun, along the path of a planet. It is not a protostar left unfinished. It is a gas giant planet that developed extremely successfully. So, perhaps a more accurate way to say it is that Jupiter is not a failed star. It is a successful planet to such an extent that it makes us think that it once had the chance to become a star. And its not becoming a star may actually be a blessing for the solar system. Because Jupiter plays an extremely important role with its enormous mass, it is like the gravitational architect of the solar system. In the distant past, Jupiter's gravity affected the distribution of asteroids, the movement of matter, and perhaps even the process of formation of the inner planets. It can both protect and pose danger. Sometimes Jupiter's gravity pulls comets and asteroids out of orbits that could threaten Earth. But at other times, it can itself throw small objects deeper into the solar system. Jupiter is not simply a perfect shield. It is like a powerful giant standing in the outer region, silently controlling the flow of rock, ice, and gas in space. And around that giant is an entire kingdom of satellites. Io, the most violently volcanic moon in the solar system, continuously erupts under the tidal effects of Jupiter's gravity. Europa, the mysterious icy world, may be hiding an ocean of water beneath its ice shell. Ganymede, the largest moon in the solar system, is even larger than Mercury. Callisto, ancient and full of impact craters, is like a fossil archive of the early solar system. If Jupiter is the king of the planets, then these moons are its kingdom. A miniature solar system orbiting a giant planet is a long step in understanding, and that makes the story even stranger. Jupiter does not shine like a star, but it still has an entire system of celestial bodies orbiting it. It is not the center of the solar system, but within its sphere of influence, it is almost a sun without light. It does not illuminate its moons with nuclear fusion, but its gravity can knead, heat, distort, and transform them from within. Look at Europa. Its surface is frozen and covered with ice. But beneath that shell may be a dark ocean, kept warm not by sunlight but by the gravitational pull from Jupiter. A planet that cannot become a star can still indirectly provide energy to the worlds around it through its own gravity. That is the strange beauty of Jupiter. It does not need to ignite to create influence. It does not need to shine to become great. But inside Jupiter, the story still continues. This planet is still contracting very slowly under its own gravity. That process releases heat into space. Therefore, Jupiter not only reflects sunlight, it also radiates energy from deep inside. Although it is not a star, it is still a living celestial body in its own way. Hot inside, stormy outside, with a magnetic field enveloping space and moons constantly moving around it. If the sun is the blazing flame of the solar system, then Jupiter is the heavy heart of darkness. A giant mass of gas that cannot ignite but is never silent. It rotates so fast that one day lasts less than 10 hours. It creates storms that last for centuries. It emits radio waves. It surrounds itself with a gigantic magnetosphere. It pulls, pushes, captures, and breaks apart objects that pass by. It is proof that in the universe, not only things that shine have power. And perhaps that is why the term failed star is both correct and unfair to Jupiter. What is failure? It is not achieving the intended goal. But did Jupiter ever want to become a star? No. It is not a flawed draft of the Sunday. It is not a forgotten star. It is the result of very specific physical conditions in the early solar system. It acquired exactly the amount of matter that it could acquire. It developed into the largest planet in the Sun's family. It has maintained an irreplaceable role in the structure of this planetary system, and by not becoming a star, it helped the solar system retain its familiar shape today. If Jupiter had ignited, perhaps we would not be here to tell this story. If it were too massive, the solar system might be more chaotic. If it were too small, the process of planetary formation might have been different. Jupiter exists in a position that is just strange enough, just powerful enough, and just stable enough to become one of the most important characters in the history of the solar system. It is not the second sun, but it is the closest thing to an unformed sun that we can observe within our own planetary system. And when human spacecraft fly past Jupiter, when they capture the swirling cloud bands, the giant storms, and the brilliant auroras around the two poles, we are not only looking at a planet, we are looking at one of the great questions of the universe. Where is the boundary between a planet and a star? How much additional mass would it take for a dark gaseous world to become a source of light? How much matter must be lacking for a future star to remain forever immersed in darkness? Jupiter stands right on that boundary, with cold planetary darkness on one side and the blazing light of a star on the other. It did not step into the light, but precisely because of that, it became another kind of legend. The king of the planets, the silent ruler, the giant that does not burn but still causes the entire solar system to feel its influence. So the next time you look up at the night sky and see a bright point standing out among countless stars, remember that it could be Jupiter, a gigantic world rotating in the darkness, a planet containing the ingredients of a star but lacking enough mass to become one, a celestial body that once stood very close to the boundary of a different destiny. And perhaps that very failure is what makes it great. Jupiter is not a failed star in a sad sense. It is a reminder that in the universe, not everything great needs to shine. There are worlds that do not emit their own light, but still play a decisive role in the fate of other worlds. There are giants standing silently in the darkness, not as brilliant as the sun, not sparkling like the stars, but possessing enough power to shape an entire planetary system. And Jupiter is such a giant, a sun that never ignited, a failed star in the language of imagination. But in scientific truth, it is not a failure at all. It became exactly what the solar system needed, the king of the planets.